R is the resistance. And then you have the IV practical tool, which is used to investigate IV characteristics of circuit elements, including a filament lamp, a diode, and a resistor at a constant temperature. All right. And then you need the last one for P1 is density. So now if you have a regular shaped object, right? If you have a regular shaped object that has got, this is a 2D drawing, but if it's a 3D drawing, you have length times breadth times height. Now you can work out the volume, which would be centimeters cube. All right, that is volume. But if you have a structure of irregular shape, you use displacement. And you need the Eureka can. Yes, you need the Eureka can or displacement can, which you can use. And the way you use it is you put the material inside, and the amount of water that's poured off, you collect in a measuring cylinder that is equivalent to your volume. All right. Another question talks about the alpha particle. So this is one of the questions. You have the alpha particle, plus and plus. Yeah, you have the alpha particle, none and none. And then you have inside the helium. So you can be given this as a question and you need to work it out. Now the difference between the alpha particle, I don't know if you can see this very clearly, the alpha particle and the helium, this is helium atom. Yeah, in one of the questions you were asked to work out the size of the average size is 1 times 10 raised to the power minus 10. Okay, that is the average size of the helium. Yeah, and if you have I'm trying to look for some other questions I have not covered. Right, I'm on the alpha particle now, and then that's bigger. The difference is that here you have electrons and here you don't have electrons orbiting around the nucleus. So those are the difference, and the mass number is 4, and then yeah, the mass number is 4 and the atomic number is 2. Okay, another question says, why is the helium atom neutral? The helium atom is neutral because it has the same number of protons and electrons. And if protons are positive, electrons are negative. So they kind of balance each other out, which is why when you have sodium, it's an atom, but when it loses an electron, it becomes an ion. So a charged atom is an ion. This is just an atom, and it is neutral. Okay, and then they talked about potassium 40. Potassium 40, yeah. Changing to calcium, so it says it decays to calcium 40 and 20, obviously with that giving off. All right, and it says what's the difference? The mass numbers are the same, the atomic numbers are different, and this one has an additional proton with it. All right, and then it says that the activity of a sample of potassium was measured 3 times, and they gave different readings of 4906, I believe, and 488. I've kind of memorized it. And the third one was 4956 BQ. And he said, why was that? Is because of random radiation. All right, because of random radiation. That's why you can read that. And then half-life. Yeah, who remembers half-life? Who remembers half-life? This sort of question that I've asked you is actually on paper 1 on the AQA. It's not P2. It's P1 on the AQA. I pulled it out from the exam board's assessment materials. It's actually on paper 1 for the AQA. All right. So yeah, I believe momentum is paper 2. Exactly. Someone's giving me the definition of half-life. The time taken for half of it to decay. So if you're given a graph, right, please watch this. You will be given the time, yeah, in hours, in minutes, in millions. See my yeah. All right. Okay, then it's all right. You're excused, Zach. Okay, and then you can. I'm going to upload it. Don't worry. I'm going to upload it. All right. So the time can be in millions of years, thousands of years. Yeah, and then you're going to have the mass here. So always, if they say this is 2,000 grams or whatever mass it is, please watch out for where the graph begins. Don't just go 2,000. You have to look out for where the graph actually starts, and then half it, trace it here, and then trace it to the time. That is how to read off a graph of half-life. Okay, no problem, Zach. I'll upload the video so you can watch it later. All right. And then I'm looking at a few more things. I'm rounding off. I've pretty much covered a lot of the things that I wanted to cover. Yeah, remember how to calculate your efficiency. I don't take anything for granted. He says, can you? The national grid. All right, yes, I've got questions about the national grid actually. Where is it? I've got a question about the national grid. Now, a few things to remember about the national grid is you have, wait a minute, I'm going to pull up the question. I've got a proper question from the exam board and I want to look at that right now with you. Just give me a minute, I'll pull it up. Okay, all right, I found it. So it says on the national grid, there is this particular national power station. It generates electricity at 25 kV, but a step up. Now, these are the things you look out for. A step-up transformer. A step-up transformer increases it by a factor of 16. So it then asks the question, how much electricity, how much voltage output is this? Very simple. You multiply it by 25 and you get 400 kV. Now, the reason the step-up transformer is very important is because this transformer, the national grid needs to carry electricity, generated electricity at a very high voltage to get to very far away distances, because they don't put power stations in your back garden. They don't put power stations where people live. No, they don't. So they put them very far away. So when it is generated, it will have to then pass that electricity over a very long distance to get to houses, schools, hospitals, and all of those places. Criminals beware. High voltage. All right. So because of that, it has to push it at very high pressure to get to homes. So when it gets there, you then need a step down transformer. You then need a step down transformer. So that step down transformer would ensure that it drops it down to 2. Is my calculation right? Is that 4,000 or is that 400? Is that 4,000 or is it 400? I just want to check my calculation. So hang on, you know you're doing this paper tomorrow. So it raises it by a factor of 16 times 25. Oh yeah, I was right. So it drops it down to 230 volts, because this is the one that this is kV. If you were to multiply that by 1,000, is several, but it drops it very little to 230 volts, because that is the allowed level of voltage that should come into your household, and it's safer for customer, and that is done using a step down transformer. Questions on the national grid, they're very easy to answer. They're made from pylons. Yeah, and then, yeah, that's it. Those are the basic questions that I found on the MIG. Well, God, who is this? Have you been eating some KFC? Because that makes you excited. Okay, then. Anyway, I'll just carry on. So those are the questions about, yeah. the step up and the step down transformer. Okay, those, I think I've covered by and large what I wanted to cover, and I hope you guys are okay with some of these things I've gone through. This is my third video on P1. I'm now working on P2 because I know I should be working on B2 and C2, but it's okay. I'm just going to work on P2, do it halfway, and then do C2 halfway, then do all of B2. All right, I'm going to do it. Yeah, thank you so much. That's all right. You know, you just keeping positive. Whatever you do, keeping positive. If you're ever down in your spirit, run out and get yourself some KFC chicken popcorn. It does wonders. When you're eating your KFC, you will be fine. The development of an atom, atomic theory, Dalton's atomic theory, you can look at that. You can look at collision theory. But when I was looking through the requirements and I was looking through the thinking, I did not see those things, so I didn't put it. I just tried because there's a lot to cover. But what I focus on, I pull out the checklist and I just look through what the exam board is focusing on. So those calculations are heavy. The questions I've gone on over with you on the, what do you call it? On the 6-mark question, look out for those ones. They will be on your paper. What did you say? What would you predict the 6 markers to be? I've already done my prediction. Where have you been? Where have you been? All right, I'll quickly go over them again. You need to look at comparing different ways of keeping your houses heat in your homes, and you have to give reasons for your loft insulation, your cavity, and all of those. You need to look at those things, and you need to look at payback time, like double glazing, solar panels. How do you compare them? Then you need to look at how all the 6 what do you call it, the 6 required practical. Look at those ones very well. The equations, did you just wake up? I have been doing the equations, and I've done the equations. I've done KV, the KE, kinetic energy, and by the way, different forms that energy is stored in: kinetic energy, thermal and potential, gravitational potential. I've looked at all of those in my first 2 videos. Phoebe, you're laughing your heads off. Can you imagine? They've been sleeping all day, and I've been doing the revision, and then they suddenly wake up. Don't worry, you'll be fine. I'm gonna upload this video. The video I've done today, I'm gonna upload it, and then you can watch it again, and then you're gonna go to the exam and write your exam. Sankey diagrams, have already done that. Okay, I'll just quickly look at Sankey diagram because I wanted to do this for 40 minutes. It's now 46 minutes, just because some of you are talking about KFC. All right, so what I'm gonna do, actually, I've got lots of equipment that I buy, and I don't know how to work them. So I think after GCSEs, all of you that have been watching, you have to tell me how to work my equipment, because someone's videoing it, right? And then their hand is hurting them. They can only do this for like, thank you so much. Yeah, you're welcome. Thanks, Benny. They can only hold it up for so long, and then I want to go and chill because they actually want to chill out. Okay? I'll see you next time, and you will do well. Remember to say to yourself, Miss Adelaide said it, and I believe it. It is so. I must pass because you must. Thank you for staying with me. Stay again with me next time, and God bless you.